This is the second video for this topic where we talk about interference of light. In line with the syllabus, we'll be looking at the second dot point on this page. Interference is when two or more waves overlap in the same region of space. So if we look at our diagram here, we've got a blue wave and a green wave, and you can see the sum of the waves is the resultant red wave. And you can see, for example, in this region here, we've got the blue wave having a negative displacement, the green wave having a negative, and when you add them together, negative and negative, you get this, the resultant being a larger negative. In this region here, where both are positive, you can see the resultant red wave is also positive. Now let's have a look at another example where this might be a little bit clearer. So with our top example, we've got a solid black wave and a dashed black wave. Now with the two being vectors in the same region of space, they superimpose and we can add them up and find the result. So we can see in this place where we've got a negative value for the solid line, a negative value for the dashed line, add them together and we get our resultant, which is here. In this location here, our black line is the value of 0, our dashed line is 0, and our result obviously is also 0. We can see here where we've got a positive value and a positive value, our result is this large positive value. Now looking at our second example, which the waves are out of phase, we've still got our solid black line and our dashed black line. At all cases, let's have a look at this point here. We've got our solid black line having a negative value, our dashed black line having a positive value. We sum the two together and we get 0, as they are both equidistant from the middle point. Now, because they're 180 degrees out of phase, when they superimpose, all values will be 0 in the resultant vector. And that's why we've got this blue line that heads all the way across the line of travel. Now we can have a look at a third example where the waves are not of the same frequency. We've got a blue wave and a green wave, and the resultant is an addition of the waves, which is the red wave. And you can see it's a little bit different, but notice the points where it's 0, where the red wave crosses the axes. You can see that the blue wave and the green wave are equidistant from the red wave, which is why it crosses the 0. Now when the waves are in phase at some point, they reinforce each other, and this is called constructive interference. So when both the waves are positive in value, or both the waves are negative in value, it's constructive. So we can see where we've got negative here for the blue wave, negative here for the green wave, we get constructive interference on the red wave, and same in the other locations. When the waves are out of phase, they annul each other, and this is called destructive interference. So when one wave, for example, is a positive value, the other is a negative, it's destructive, and we get the resultant somewhere in between. So if we have a look at this location here, our blue wave is negative, our green wave is positive, and we can see destructive interference where it's somewhere in between, being the red wave.